Hello, my name is Mark Olson. My student ID number is G000497222. This is my presentation for my capstone of my EE450 for Grantham University in the Bachelor of Electronics Engineering Technology degree. As you can see on the table here, I have all my piece parts to design my temperature sensor. And that's what I'm going to be assembling and showing you the complete circuit later on. Hello, now here we come to the complete circuit that I have built for this lab. What I have in front of me is the board where it has a microcontroller in the center. We have a diode on it, a number of resistors, a digital temperature sensor off to the left hand side right by the LED light. And as you can see here, I have my power supply here that's connected to the board. Three AA volt batteries, and to power up the board. And what I've done is I've done a program inside the little microcontroller, and what this does is basically turn on and off your heat in your household. Right now, with the LED light on, what's happening is the heat will not turn on in your household. So when it gets to a certain temperature in the household, then what happens is the LED light will come off, and when the LED light comes off, it will then send a circuit to turn on your heat in your household. Again, this is the complete circuit for basically to turn on and off your heat in your household, and this concludes the lab. Okay, and now after completing my project with my temp sensor, I wanted to show you another type of temperature measurement. It's called with a 4-wire RTD. And what this is, it's mostly used in laboratories and industrial environments. It's where close accuracy is required. What basically is going on here is in a 4-wire RTD, the actual resistance of the lead wires can be determined and removed from the sensor measurement. The 4-wire circuit is a true 4-wire bridge, which works by using wires like 1 and 4 to power the circuit and 2 and 3 to read. This is a true bridge method which will compensate for any differences in lead wire resistance. So you can run lead wires all the way back to a control system with 4-wire RTD as shown here, and you are able to get a very accurate measurement. As you can see here in a picture diagram on a cover that we have, that I was able to again acquire these transmitter and sensor. I wanted to be able to show you. As you can see, the bridge goes across 2 and 3. So what it is wires 1 and 2 and 3 and 4 are your wires. So 1 and 2 could be red and 3 and 4 could be white, or vice versa. 1 and 2 could be white and 3 and 4 be red. It doesn't make any difference which way, as long as you have two of the same colors going across with the 1 and 2 and then the 3 and 4. Okay, I was able to acquire a 4-wire RTD here, and along with the temperature transmitter, I want to show you what basically we're going to do is we're going to hook up the 4-wire and put it into the transmitter, which I'm showing you right here. It's inside of a terminal block, and we're going to hook up 4 wires, and we're going to have the 24-volt power supply power up this transmitter, and you're able to see where the wires are going into the transmitter and basically putting out a digital output onto the display to show you the actual temperature, and also converting it and sending it back to like a control system. On the 420 it will go out analog, but when it gets back into the control system it'll be digital again, because a heart signal over the 420 wires is what we get digital information on. And I will be showing you this here shortly. Okay, as you can see here, I do have the sensor temperature hooked up, and we run voltage, a 24-volt power supply. And as you can see, with the sensor going in here, it's at 73.546 degrees F. And now once I start touching the end of the sensor, we should see the temperature go up. As you can see, it sensed the temperature as it went up, and you can see that it now is at 76.726 degrees and so forth. As you can see, it responds fairly quickly on these temperature sensors. And this concludes my project here with temperature sensor. Thank you.